This video is to show you how to draw the histology for the urinary system lab. But let's look at what we're actually looking at. This is a kidney. It has two regions. It has a cortex out here, and you see these darker regions here? Those are medullary pyramids. So we're going to draw a structure in the cortex that's part of the nephron. The nephron starts with the glomerulus, has a proximal convoluted tubule, a nephron loop that goes way down into the cortex, and then a distal convoluted tubule. Now, that's what I had you draw in lecture. That's not what it really looks like. In reality, the nephron looks like this. Here's the glomerulus with its blood vessel going in. And then we have this orange tube. That's the proximal convoluted tubule, and it's really convoluted. It's just going all over the place. And then we have the descending limb, we have the ascending limb, and then a distal convoluted tubule all over the place. So when they make the histology slides, what they basically do, they take sections of the cortex. They're basically taking these tiny sheets, like so, and we're just getting a little idea of what it actually looks like. So, this is actually a whole piece of kidney. We have the cortex up here, and this is about the medulla, the difference between the two. Now, we're going to see these structures called glomeruli, like this. So those are glomeruluses, and they have blood vessels that go in them. This one actually has a blood vessel going in on this side, and then they have other blood vessels going out. So these are going to filter blood, so they're going to have a space. Then there's two sets of tubes. There are proximal convoluted tubules, which is probably this one, and there's distal convoluted tubules, which I know is this one, just because of where it is. And then we have the medulla. The medulla histology is very, very boring. This is what the medulla histology looks like. It's big, long columns. And that's very, very boring. You're going to have cuboidal, simple squamosal. But we're going to draw the medulla. So this is a close-up of one glomerulus. It is going to have a capsule around it, like so. Now it's going to have blood vessels going in. And they're going to be coming in this side. And I know that because I have a macula densa right there. So there's going to be an afferent arteriole coming in somewhere here, an efferent going out. Now, they exit on this side in a structure called the proximal convoluted tubule. And remember what I showed you? You have the glomerulus, then you have the proximal convoluted tubule coming out of it, and it's convoluted. Then it goes to the nephron loop, comes back as the distal convoluted tubule. It's more convoluted. So something like this is a section of all of that proximal convoluted tubule. And we are going to see that it's larger, and it is going to have these microvilli in it. So you can't really see clearly inside. This is a distal convoluted tubule. It is going to have not as much. It is basically going to have a smaller lumen, and you can see inside. So we're going to draw this picture. So we're going to start with the glomerular capsule. And fortunately, we're going to make this take up most of our structure. Coming out this side is going to be the proximal convoluted tubule. And the proximal convoluted tubule is going to have little tiny microvilli, like so. And let's draw a couple other proximal convoluted tubules, just at random. So here's one. Let's put another one sort of like right there. And remember, proximal convoluted tubules are going to have large lumens, and they're going to have microvilli. Now, the advantage of making them so nice and large is it's taken up a lot of our picture right here. So let's draw another proximal convoluted tubule. Oh, look, that's taken up most of my picture. And you have more proximal convoluted tubules than distal anyways. Then we have a blood vessel. And blood vessel is going to come in here And it's going to leave here, and we're going to have capillaries in there. And you don't have to draw them, so these are glomerular capillaries. Now in here are going to be some special cells called the juxtaglomerular cells. And these cells, they're basically right there, are watching blood pressure. Now the distal convoluted tubule that's there is a special distal convoluted tubule. These cells right here are actually cuboidal. So let's draw some cuboidal cells. I'm sorry, I misspoke. These are columnar cells, and these are cuboidal cells. So this would be a distal convoluted tubule, and that's the macula densa. Oh, there's not much space for other distal convoluted tubules, so let's draw one there. Let's draw one here. And that's about all the room I have for distal convoluted tubules. So the idea is the distal convoluted tubule is smaller in diameter than the proximal convoluted tubule. So that's the glomerulus. I never have students draw the nephron loop, so I won't have you guys. But it's basically these tubes here that are the thin loop, that's going to be simple squamosal epithelium. Then you will have a thick loop, which is simple cuboidal epithelial. Then every once in a while you will have a collecting duct. That is also simple cuboidal epithelial. But we're not going to worry about the medulla. So this is what a ureter looks like. This is going to be our other picture. Now the ureter is made up of transitional epithelial. That's going to be its mucosal layer. Then I called it submucosal just because I usually don't teach lamina propria. But this is actually not a true submucosal. There's not really many blood vessels or glands in there. It's just glue that is wrapping around the submucosal. Then we have two layers of muscle. We have the circular layer out here that's going around. Then we have the longitudinal layer that's basically coming out of the screen. So let's draw that. The first thing I'm going to do is draw the mucosal layer. It's easy to draw from the inside of the tube to the out. And the nice thing about drawing transitional epithelial is it's such an amorphic tissue. You can make it amorphic. Might delete a little bit of it. And we'll label this mucosa. The next one is the lamina propria, and this is usually attached to the submucosa of other tissues. You don't have a true submucosa. So let's do this here. Ta-da! There's your lamina propria. So, our next layer is our muscularis. Now there's two layers to this muscularis. They're both thin. The first is a longitudinal. So they're going to be going north-south, just like our tube is going north-south. And now we're going to draw the circular muscularis. This one's a lot easier. Around it. Now, the connective tissue outside of it is technically an adventita. So let's draw that in. And the difference between a serous being in the outside layer, like an intestinal tract, and the adventita, like here in the esophagus and the arteries and the veins, is a serous membrane is going to have a second part of the membrane and fluid around it. This does not. So this is why this is an adventita and not a serous covering. I personally like just to call it the external layer, but I cannot do that. So this is the adventita. And that's our histology. So we've already looked at transitional epithelium in the urinary bladder. I don't see a reason to make you do that again. So we are all done. Have a good day.